video, we're going to talk about how to find the real roots on a graph. So it says use a graphing calculator to graph each function, sketch the graph, then answer the questions. So we have f of x equals x times x minus 2 times x plus 4. Now you can either use a TI-84 calculator or any Texas Instruments graphing calculator, like the ones that we have in class, or if you're not in class, you can use Desmos. Right now I'm at home, so I am going to pull up Desmos. So I'm just going to desmos.com/calculator, and I'm going to type in that function. So I have x times x minus 2, and I'm just typing on my keyboard, and then x plus 4. And so this is that function. And the nice thing about Desmos, and this is where it has a leg up over TI, is that instead of having to sit there and trace your graph or look for the zeros, you can just click on each point. So here I can see that -4 is a 0, 0 is a 0, and 2 is a 0. Now when I'm saying that they're a 0, I'm saying that they are an x-intercept because this is where they cross the x-axis. And so I'm going to go ahead and plot those points on my graph. There we go. So we had -4, 0, and 2. So those were where my x-intercepts were. Now this is a cubic function. I know that because if I were to multiply these x's together, like if I were to go ahead and multiply this whole thing out, I would have x cubed. Another way that you can know that it's cubic is because it's crossing the x-axis in 3 locations. And if we look back at Desmos, we can see that that's the general shape of our cubic function. So here, let's see, it is cubic. So we're going to start down here, and then it went up, and it came back down, and it went back up again. Now, where this is, it doesn't need to be perfect. What I really care about is that your end behavior is correct and that your intercepts are correct. So when it says what are the zeros of the function, it's asking for the x-intercepts. So that is at -4, 0, 0, 0, and 2, 0. Now, the nice thing about these things is that you can kind of see the zeros when you're looking at your equation if it's factored out for you. Remember when we solved quadratics, we used the principle of zero products to solve. You can use the same thing here. So I'm going to let f of x be 0. And so I would have 0 equals x times x minus 2 times x plus 4. So then I have x being multiplied by x minus 2 being multiplied by x plus 4, and that equals 0. So I could say, okay, either x equals 0, x minus 2 equals 0, or x plus 4 equals 0. This one's already solved for. For this middle one, if I were to add 2 to both sides, I would get x equals 2. And if I were to subtract 4 on both sides, I would get x equals -4. So your zeros come directly from your factorizations. Then it says, how many times does each 0 occur in the factorization? Well, I only have one x, so that just gives me 1, 0, so that's once. I only have one x minus 2, so that one only happens once. And I only have one x plus 4, so that one only happens once. So x equals 0 happens once. X equals 2 happens once. And x equals -4 happens once. At which zeros does the graph cross the x-axis? So here it's saying it doesn't just touch and turn around, it goes straight through it. So remember, this is your x-axis. And for -4, it crosses it. It goes straight through it. At 0, it crosses. And at 2, it crosses. So at each of them. So at 0, at -4, and at +2, it crosses. And then it says, at which 0 is the graph tangent to the x-axis? And here we don't have any. Tangent would be if it were to look like this. I'll do it in a different color. So if it were to touch it and then turn around. So it doesn't cross it because it doesn't go straight through it like how it did here and here and here. Here it would touch it and turn around. That would mean tangent. So because that's not doing that here, none of them are tangent. Let's try that again with this next one. So here I have g of x equals x minus 4 squared times x minus 6 times x minus 8. So I already know by looking at this what my zeros are going to be. I'm going to have a 0 at, if I were to solve this, I would have a 0 at 4. I would have a 0 at 6 because I would have to add 6 to both sides. And then I would have a 0 at 8. And if you're like, I have no idea where you're getting that from, I don't understand, I'm just using the principle of zero products, which would say that I would have x minus 4 equals 0, x minus 6 equals 0, and x minus 8 equals 0. The x minus 4 would happen twice, but I only have to write it once because it would be the same x-intercept. If that's confusing, again, you can just head on over to Desmos. So I'm going to delete that one, and I'm going to type in our new one. So we have x minus 4 squared times x minus 6 times x minus 8. And so if I look over here, this is what my graph looks like. And we can see those x-intercepts are happening at 4, 6, and 8, just like how I had earlier. So this one is kind of W-shaped, but you know, this part of the W down here is a little bit lower, and that's all right. So let's go ahead and draw that on our graph. So we start up high, and we turn around at 4, we go through 6. Oops, let me fix that. So we turn around at 4, we go through 6, and we go through 8. And again, I'm just mimicking what was happening on this graph over here. We stopped and turned around at 4, we went through 6, and we went through 8. So, what are the zeros of the function? Well, those zeros are these things right here, 4, 6, and 8. So those are 4, 0, 6, 0, and 8, 0. How many times does each 0 occur in the factorization? Well, you get your hints from the factorizations here. Here we can see that x minus 4 happens twice because of the exponent of 2. And that's actually why we're stopping and turning around there. So x equals 4, that one occurs twice. And again, that's because of the exponent of 2. When x equals 6, that happens once. And when x equals 8, that also happens once. At which 0 does the graph cross the x-axis? So it's crossing the x-axis here, and it's also crossing the x-axis here. For x minus 4, let me grab my thingy. Here we go. Here, that's where it's stopping and turning around. And if you'd like a better representation of that, here's Desmos. You'll see at x equals 4, it stops at 4 and turns back around. But at 6, it goes straight through it, and at 8, it goes straight through it. So, at which zeros does it cross the x-axis? That's happening at 6 and at 8. At what zeros is the graph tangent to the x-axis? Well, that is happening right here where x is 4. That's where it stops and turns around. So that is what it is asking there on that one. We're going to do the same exact things here on examples 3 and 4. So I have my first factor of x plus 3 cubed. So that would be if x plus 3 equals 0. If I were to solve that, I would have x equals negative 3. And then my other factor is x plus 7. If I were to solve that by using the principles of zero products, I would have negative 7. And if that's a hard thing for you to visualize, again, this is why Desmos is your friend and why we love it so, so much. And so we'll say, okay, x, was it plus 3 squared times x plus 7. And when I graph that, I just gotta zoom back out. And there we can see it. Oh, that wasn't, is it squared or cubed? That was cubed. Let's fix that. And we want that cubed. There we go. So this is what this graph looks like. So we have an x-intercept at negative 7 and at negative 3, just like how I had solved for. So negative 7 and negative 3. So let's go back to our graph and let's see. So it started up high at 7. And then for negative 3, we kind of have a squiggle through. And if you look at Desmos, this is that squiggle through that I'm talking about. It kind of touches it and squiggles through it. So it says, what are the zeros of the function? The zeros are the x-intercepts. That's at negative 3 and at negative 7. How many times does each zero occur in the factorization? Well, negative 7 only happens once, but negative 3 occurs 3 times. And I know that because the exponent is 3. And then this little squiggly thing that's happening there, that's what happens when it goes through 3 times. So we say that this has a multiplicity of 3. If we were to look back up on this one, here 4 would have a multiplicity of 2, saying that it happens twice, and then saying that this one happens 3 times. So we call it a multiplicity. At which zeros does the graph cross the x-axis? Well, it's crossing the x-axis at negative 7 and at negative 3, so at both of them. And at which zeros is the graph tangent? There are none that are tangent. Tangent means it touches and turns back around. Both of my zeros here are going straight through. And then on this last example, we have x plus 5 raised to the 4th power. So here I know that I'm going to have a 0 where x equals negative 5. And if you're not sure, you can go ahead and pull up Desmos. So again, that is x plus 5 raised to the 4th power. And so here that 0 is at negative 5. So this one kind of looks like this. So the zeros are negative 5, 0. And how many times does each 0 occur in the factorization? Well, this one is happening 4 times. And that's because that exponent is 4. At which 0 does the graph cross the x-axis? None. I'm never crossing my x-axis. But I am tangent to the axis because here we touch it and we turn around. And so that is at x equals negative 5.